Hey, what's up? I'm doing a pivot from the research paper. So just for some context, the GAN paper is something I've been trying to contribute to for a while now. GAN is a geometric informed neural network. So what I was planning to do after reading the paper and seeing the Siren and Soft Plus architecture within those papers, I was planning to introduce a new architecture to improve the latent space to improve the interpretability, the explorability of the latent space. So you could have a better transition from a thick shape to a thin shape to a small, big. You get the idea. However, within the code base of the research paper, there was a new architecture introduced called the wire architecture, and it basically addresses a lot of the problems with the soft plus architecture and the siren architecture. And I don't think it's worth it to just have like maybe a plus one and plus two improvement, especially for the workshop I'm going to. The track I'm applying to is more so about having a novel perspective or a different perspective. So I think just adding like a just metric boosting is not going to be enough there. So what I'm thinking, what I just realized this morning is that something that really pisses me off with this, right? Something that makes me, I'm not emotional, but makes me really interested and really annoyed is that the way this whole thing works is that to generate a cylinder or a jet engine bracket or a jet engine bracket, you have to basically define the constraints and then you get that shape. So it's not a matter of like, okay, you have one universal constraint and you can get a cylinder, you can get jet engine bracket, you can get this and that. But what I was thinking of is that it's really hard because all those shapes are very different from one another. But shapes that do seem similar are Legos. Legos are a really great, I don't want to say analogy, but a really great representation of engineering because you have these different shapes that you can put together to build bigger stuff that work really well in conjunction with one another, all those stuff, right? So I'm thinking since Lego bricks are kind of, they're all very similar because they have to be able to go into one another, they're a great thing. They're a great way to explore this idea of a universal constraint. Because think about a Lego book. You have like your two by four, your three by four. Sorry, you have your two by N, one by N, and you have your studs. You have your bricks, you have your flat bricks, and all of those have like these similar shapes. So what I was thinking is if I could use Lego as a means to show a universal constraint, it could mean something in the future where we have a large geographic informed neural network that can create more complex shapes by um, by using less constraints, right? So it doesn't need to be one per shape. It doesn't have to be one constraint per shape, but it could maybe just be like one universal constraint, maybe like a few universal constraints. With Lego, I do think I'm fortunate because since Legos are similar, and then a lot of the differences in the different categories of Legos are largely just size. I think that it could just be a set thing where, like in calculus or calculus two or wherever, um, there's equations where you can have like, okay, if the equation is less than 10, you do this. If it's zero, you do this. If it's more than 10, you do this. Right, you can do that. So that's basically what I'm thinking with the height of the Lego bricks to kind of differentiate it, so the model is able to perform, or the model is able to understand different Lego categories since they're still the same. And then I think there's certain stuff you can just like make sure it's like built in. So like the difference between all these studs, like the studs on top of the brick. I really wish I had an example here. But the different, it's like that size is fixed, right? So no matter what you do, no matter what Lego brick it is, that size is fixed. So that's something that's pretty easy to do. I think the only thing that really differentiates is the size and the only thing that differentiates is the height, right? That's the big differentiator. Um, but yeah, I'm excited. I think this could be something that's really, really, I don't want to say really, really novel, but I think it'd be really exciting. I think it's very visual, which is a big, which I think is just, it's just subconsciously a big factor in and how interesting something is. So I think that could definitely help me in my case. I think it's something that does really mean a lot in the future of the design engineering, design synthesis, or in the sense that I already said this earlier, but like if you could have this universal constraint, imagine what it means for a model to be able to just generate anything off the bat. I was even thinking with this, and something I would really love to have. I think it's a couple months off, or maybe a year off, but maybe like having a VR system where a model kind of just is able, like just intuitively knows how to best teach you through different shapes. Like let's say I'm talking about like the let's say I'm talking about the solar system. Like you could just generate those shapes offhand. It's like it's not just picking and choosing. It knows how to best represent those ideas. And that's a bit like far from this research. But the idea is like if it has an intuitive understanding, then I think you could have a world model that's really able to generate anything, right? So it could just be like, okay, let's say I'm in a system where I want to show off a black hole. It could really just generate all those shapes in one go. And I could talk about a bunch of different stuff there. Like we'll be able to generate a 3D mesh of that. I think that'll be really cool. But that's way off of this research, but it's a future direction for sure. So I'm excited. Besides that, though, I have nothing else to say. So have a great day.